Hello, welcome to Clam demo video. In this video, I will try to recognize test dimensions and its associated values from clinical notes. So our goal here is to recognize all these test dimensions and then attach it with its associated values. We'll use Clam to finish these three subtasks: corpus annotation, model development, and pipeline development. Let's go to the Clam interface. So usually to develop machine learning model, we'll start from corpus annotation subtask. In Clam, we can click this new project button and then input project name, say Labtest annotation, and then choose this corpus annotation subtask. So when you create a new corpus project here, you have a tab definition XML. This is a place where you can define your own semantic tabs. In this task, we can define two tabs. One is for lab test and the other one is for value. So we can open this tab definition, right click on this entity, and then say add child, new element. And we define a semantic tab called test. And then we can define another one called value. So after define this, we can copy paste some clinical notes into Clam. And then if you double click on this note, Clam will convert it into Clam format called XML file. So on this XML file, you can select something and then assign a semantic type. For example, we think this white count, that's a test name, and this number, it's a value. This is a test, this is a value, this is a test. And also, this is a test. And this stable, so we can say it's a value. That's for entity annotation. And in this type definition, we can also define some kind of relationships. So if you add child, we can add a relation here, say value of. And for this relation, we need to define attribute. Say the relationship from a value entity, and it should go to a test entity. So here we define this relation. And if we go back to the clinical notes, we can drag from this value to the test to annotate the relation. Drag and drop. Drag and drop. Yeah. Okay, that's how to annotate corpus using Clam. So about this type definition, we have an interface here, and if you're familiar with the XML, you can always go to the source tab here. Actually, that's just regular XML files. Under the entities, we have the semantic type definition. And the relations, we have the relationship definition. And the from to, that's just the XML attribute here. Okay. So yeah, that's only one note. I have prepared some of the annotated corpus. Oh, Okay. So in the training folder, we have 50 annotated nodes. And for each nodes, we have the all these concepts annotated and the relation annotated. Once we have the annotation, we can start to develop the machine learning model. In Collab, you can simply select the training folder and then select this training icon here. In this training icon, we have a list of all the NER features. You can try different combination of the features to optimize the performance. But usually if you select them all, you can reach a reasonable performance on clinical notes because these are all proven features, proven to be effective. And also we have evaluation options here. For evaluation, there are two approaches. You can use individual test set here or use the cross-validation. And after configure the training dialog, we can say start training. Then here it's the training process is running. Yeah, the training part is sometimes time consuming, so I just cancel it. Um, I have a model here. So after the model training, you will have this model folder here, and inside this folder, you have the model JR, and you have the training log here. So in the training log, you can see the actually the performance accuracy of the machine learning model. If we go all the way to the end of this log file, oh, yeah. So we can see there are um, 700 annotated as a test, and the F score here, and F score for lab value. Of course, these numbers are not very good because we only have 50 nodes here. If we can reach, for example, 300 annotations, these performance should be higher, 80 something. Okay. So now we have the machine learning model. In order to use this model, we have to go to we have to create an NLP pipeline. So you can see new project and then lab test NER pipeline. So this pipeline file it's empty and we need to drag and drop from the name entity recognizer CRF base 1 to this pipeline and then try the autofix. So there are errors say in order to run the CRF you need to send the detector section tokenizer or something. Try this autofix and it will add this dependency automatically. And we have the CRF by default it's recognized problem treatment test. And in this task, we are trying to use our own models. So we can copy this model file, paste to this CRF name entity recognizer, and then change this configuration. It's default model now. Let's switch to this model, new generated model. Okay, so now we have a runnable pipeline. Next step, we need to import some test data. Uh, okay, so try to run this pipeline, click on the run pipeline button, and then can review the output in this output folder. Double click on this one. Yeah, you see all these test dimensions and values are recognized. So the model we trained is a name-entity recognition model, so it doesn't cover the relationships. In order to connect them, we have to add some router rules. Go back to this pipeline, and then NLP components, router rule engine, drag and drop this router script file here. And then let's go back to the notes. Yeah. So we have that router rules, and then we can create some rules either using the interface or just type the router script there. For example, if we see, say, block group was a RH positive, this one's supposed to be value for the blood tab. So we can select this phrase, and then I will try to, it will pop up this interface, say if we check the tokens from position 0 to position 4, if it's matched this sequence, and then we can assign this phrase as a test. Now it's a value. Okay, after doing this, we can go back to the router script and double click it. It has a router rule generated by the rule editor. We need to further refine it a little bit to generalize this rule. For example, this rule is talking about tab A only. Maybe we need to add the tab B or tab AB or tab O. And for this punctuation, we may have that, we may not have that. So use the reluctant match here. And RH positive, don't have to use this punctuation. And then from the first token to the fourth token, that's a value here. So this one could be positive, could be negative. And then save everything, run the pipeline again. So this phrase is recognized as a value. Okay, let's try to create the relations. So based on the text, we see if a value is right after a test, then probably it's we can create a relation between these two. Then we can type something like lab. I think I have that. Yeah. Okay. So for this rule, if we see for each sentence, if we see a test and followed by a value, and then we create a relation from this value to the test. Run it again. If we go back, say these two are connected, but the relation type here is null. Unfortunately, I cannot use the router rule to assign the type here. So in clamp, we have another user-defined components here, say relation connector after router. Drag and drop this one and double click on it. We have a configuration of this router relation connector. Say if it's from I think I use a test value here. It's from test value to actual test, and then the relation name should be value of. And then save everything, run it again. Now we have the name on the relation, but we still see some problem here. For example, product group was. Uh, yeah, let's update our rule a little bit to match this one. So it's talking about there's something between the test and the value, but it's not always there. So we can use the reluctant match here. Say use this or not, regu no. So it says try to match value first. If it's not a value, and then try if it's the token is a was. And then let's try to run it. Oh, I have to update the index as well. Yeah, now you see this one is also connected, and we need to not, generalize that rule a little bit. So that's the rule. So it's set semantic type is test, and then followed by one or two word. Could be test currently is something, or test now is something, and then the value. Yeah. Mm. Okay, we can do similar things if we found there are some errors. For example, heart rate was regular. Regular is not recognized as a value, and then we can create similar rules here. Say if a bit token it's at the value of stable, and then we say maybe a value here, and then see the text. Yeah, so this one is connected. And also for this pH, um, go back to the router and pH. If we see a token match this pH, and then it might be a test. So run it. It's connected now. Yeah. So if you go through a text, they will find a problem here. There's a value, but this value is not associated with anything. So it I think we need to remove this standalone value here. And in order to remove this standalone value, we can also write a router rule. Try to clean up all the standalone value. That should be at the end of this router file as the last step of the rule matching. And then run it again. Yeah, it's gone. So that's all about this demo video.